let's take a look. So, oh, I know. Okay, so let me 99% confidence interval. That's this one right here. And what's my n? N is 18, so my degrees of freedom is 17. Slide over to the 99% confidence interval. 2.89. Oh, you can't see that. 2.898. Are you on board? Yeah. All right, so 17 over to the 99% confidence interval, 2.898.
Like military time, so they could say something.
All right. Great. Some general notation. Again, mu is the same thing as mu naught. There's the mean. X bar is your sample mean. S is your sample standard deviation. N is your sample values. E is your margin of error. And my critical value, also known as T alpha over 2, is the critical value T separating an area of alpha over 2 from the in the tail. So remember, in your homework will call it T alpha over 2. It's the same thing as the critical value. Don't get thrown off by that. All right, procedures are exactly the same. I find my mean plus or minus my error. In order to do that, I need my X bar and I need my E. X bar is given. E is going to be found by doing my critical value times S over square root of N. The only difference is my critical value is not from the Z table, it's from the T table. How do I remember which one? Who's ever heard of Mr. T? He's a big guy, mean looking, right? He's not really mean, but he looks mean. So mean looking Mr. T, mean T table. Everybody on board? Yeah. Mean Mr. T, mean T table. The other one, proportions, Z table. Easy peasy. That's what my students said. They said, oh, it's easy, remember easy peasy. Easy, P, proportions, Z table. PZ, proportions, Z table. Mean Mr. T, means you're going to use your T table. All right, here's an example. You are doing this with me. All right, this is in the middle of your, this is at the bottom of your paper, of your page. Right, the example. You're going to be writing stuff in with me. I need a good reader. Who's a good reader? Great, go ahead. Thanks, Ryan.
A common claim is that garlic lowers cholesterol levels. In a test of the effectiveness of garlic, 49 subjects were treated with doses of raw garlic, and their cholesterol levels were measured before and after the treatment. The changes in their levels of LDL, cholesterol in milligrams, and
don't worry about that. Deciliters.
Have a mean of 0.4 and a standard deviation of 21.0 points. Use the sample statistics. Sample statistics of n equals 49. Mean is 0.4 and s equals 21. To construct a 95% confidence interval estimate of the mean net change in LDL cholesterol after the garlic treatment.
Perfect. That's good. Awesome. Thank you. All right. So I have my n is 49. My X bar is 0.04. My S is 21.0. My confidence level is going to be 95%, which means that I'm going to find, I need to figure out, so here I've got N equals 49, X bar equals 0.4, S equals 21.0, and you find my critical value. So my critical value, let's see, if my N is 49, it means my degrees of freedom is what? 48. And since my confidence level is 95%, degrees of freedom 48, Well, if I go down there, everybody take a look. So my degrees of freedom, 48, I get a choice of 40 or 60. Yep, it's closer to 40. So I'm going to use 40. And what's my degrees of freedom if I go to 40? Let's see. 95% confidence interval. 2.021. Everybody on board and good with that part? So my critical value is going to be 2.021. Now I need to find my error. So my error, my step 1 is finding my error. It's my critical value times S over square root of n. My critical value is 2.021. My S is 21.0. My n is square root of 49. Oh yeah, I remember this. This is great because square root of 49 is just 7. 21 over 7 is 3. Everybody with me?
Yeah.
So this is just 3. So this is 7. 21 divided by 7 is 3. So 3 times this. 2 times 3 is 6. 0 times 3 is 0. 2 times 3 is 6. 1 times 1 times 3 is 3. So this becomes super straightforward. 6.063. I need a calculator for that one. That's nice. Next one. Step 2. I need to find my.
The screen turned on.
Oh, darn it. I need to find my error plus and minus my error plus and minus my my mean plus and minus my error. So you take my x bar, everyone write down x bar minus e, comma x bar plus e. Everyone write that down. So what is that? What's my x bar? Figure out what your x bar is. 4.4 minus my error. What's my error? 6.063, comma 0.4 plus 6.063. If I add those, I will get negative, 5.663. Yep, to 6.463. There we go. Now I think it's going. Okay, so if you folks didn't get that, it's coming up right now. Just make sure you write it down quickly. Or take a picture of it, actually, would be better, maybe. All right. Good. So then the question is, what does that confidence interval suggest about the effectiveness of garlic in reducing cholesterol? Well, my cholesterol levels, they might have gone down to 5.666, but they also might have gone up 6.4%. So points. So it may have lowered my cholesterol, or it may have increased my cholesterol. That's not really very effective, right? And in fact, my mean was 0.4, so it actually looks like my cholesterol went up a little bit. So it does not look like garlic is super helpful in reducing your cholesterol. Good? Does that understand why? Because yes, and so it could have the range is either negative something or positive something. It could be anywhere. It could have lowered your cholesterol, or it could have raised it. Now, what someone pointed out is if my entire confidence interval, Ryan, was negative to a negative, then that'd be good evidence that it lowered it. Does that make sense for folks? But because 0 is included, it might have lowered it, or it might have raised it. Okay. Here it is prettier. They used a more accurate number because they had a better table, I guess. And here's some more information they said. Okay, so you folks need to do lab number 8. So those are all your pieces. Remember, use your t-table. Degrees of freedom, n minus 1. You need your N, you need your S, you need your X bar. You also need to figure out what your degrees of freedom is from your N, and then you need to find your critical value from the T table using degrees of freedom of N minus 1. All right, listen up. Nicole's going to explain what she did. Nicole, go ahead. Okay, guys, quiet. Listen up. Hey, folks, don't be rude. Listen up.
So the sample size N is 10, the sample mean is 9.8, the sample standard deviation is 0.96, the, how do you say that again? The CV, whatever.
Critical value?
Critical value, that's what it was. 2.262, and the DT is 9. So I just use the critical value over the square root of the sample size, and then, so that's 2.262 times 0.96 over the square root of 10. I got 0.69, and then I got my confidence interval with the sample mean minus the error, and then the sample mean plus the error.
And then, since my data, my S, between my S and my X bar, the most they have is 2 decimal places, so your answer should have 2 decimal places. Does that make sense for folks? Just go with whichever one, between the mean and the standard deviation that they gave you, whichever one has the most decimal places, use that one. They got the same answer, they just slightly different. And then they got the same. All right. Just like the one for proportions, you can again find your point estimate X bar, because remember we take the X bar, we subtract our error to get our lower limit, take our X bar and we add our error to get the upper limit, so it's smack dab in the middle of them, right? If we want to find our X bar, we just average those two. So you add them up, divide by 2 to find the mean, the error from the upper limit to the lower limit. Here's my X bar. Right, you add an error to get here to your upper limit. You subtract an error to get down to your lower limit. So the distance between them is 2e. So if I want to find my error, I just find the distance between them, take my upper limit, subtract my lower limit, divide by 2 to get 1e. So that's what they did on the bottom part. You can write those down if you like. If you might find them useful. Yeah, probably. Okay. Here's a little bit of notation, which again is all stuff that you folks kind of know already. Mu is your population mean. Sigma is your population standard deviation. X bar is your sample mean. E is your margin of error. And critical value is the z-score, separating your usual values from your unusual values. Right? Now, finding a sample size for estimating population mean, we can find n from our error by, again, squaring both sides and then multiplying both sides by n and dividing both sides by e squared. That's the formula. I'm actually not going to have you folks do any of those for the very reason that here's one, just in case you want to look at one. You might have one. I don't think you have one in your homework. You might have one in the homework, but it's pretty much plug and play. The problem with it is that you can't find your critical value because it depends on the t table, right? So then you don't really know what you don't know what that's going to be because it depends on what your n is. So it's just too many moving parts. So you'd have to assume that you know what sigma is, and that's just kind of, again, not realistic. So I'm not going to really emphasize this or harp on this at all in any way, shape, or form. So this will not be on the exam, obviously. But there you go. All right, we do want to look at choosing the appropriate distribution. So again, the top one, where you have a mean, you're trying to find the population mean, and you know the standard deviation, the population standard deviation sigma, that's unrealistic. So we're not going to use that. That's crossed out. The one we will use for the mean is when we don't know sigma, so we're going to use S instead. And remember, whenever you use S, you're going to use, for a mean, you're going to use mean Mr. T. So all of our means are going to be with S, mean Mr. T, T distribution. For proportion, you're going to use what you've always been using, the Z table. So proportion, trying to find, you have P hat, you're trying to find P naught, easy peasy. Proportion, Z table, PZ. Here's something else that's kind of cool. So now, you don't really need that T table, except for maybe those numbers that you wrote on the side for the homeworks. You don't need it because I want to grab your T table. Look at your T table. Look at the bottom row of your T table, where it says sigma known, infinity. That is your Z table. So the only Z tables you need, the only numbers you need from a Z table for chapters 7, 8, and 9 are just these little ones here. If you look back at your table, what was it for, what's it for a confidence interval of 90%? 1.645, exactly what's in here. All right, so if you look at your page 2 table, everything on here matches up with this one here. 95%, 1.96. 98%, 2.33. This is 2.327. It's just, not rounded. It's rounded to 3 instead of 2. And for 99%, 2.575. This is 2.576 because they round it a little bit differently. But that's, so you don't need this table for your exam because now you have it in the bottom row here. If you want to, you can write at the very bottom next to that infinity symbol, you can write in Z table right along the bottom, just for that bottom one, because that bottom row is your Z table. Just the bottom row. Everybody on board? Yeah. All the rows above, all these other rows, that's your T table, but that very bottom row is your Z table, just the bottom row. And if you also want to write in the corner, you're also allowed to write degrees of freedom equals n minus 1. df equals n minus 1. You can write that in there as well if you like on the table. All right. So now we're done with that packet. We're going to take a look at your chapter 8 packet that you just got. We're going to look at a couple things in here very, very quickly. First of all, a skill hypothesis is a conjecture about a population parameter which may or may not be true. The null hypothesis, symbolized by H naught, states that there's no difference between two parameters. In other words, they're equal. So H naught is always, always, always equal. Everyone say that with me. H naught is always equal. Ready? 1, 2, 3.
H naught is always equal.
Always equal. H naught is always equal. So for the sample we did earlier with the cards, our H naught was that my deck is the same as, is equal to all the other decks. So my proportion was the same as everybody else's. It equaled 0.5. Right? Red card, 0.5 red cards. H naught is always that it equals. So then we try to either reject or not reject H naught. H1, the alternative hypothesis, H1 or HA, is some alternative hypothesis. It's going to be something different, which means that it's going to be either less than, greater than, or not equal to. H naught is always going to be equals, so H1 will always be some other symbol. Less than, greater than, or not equal to. Always. Yeah, Lauren.
Would you mind going back to the last slide real quick and reminding us what the second portion of the null hypothesis fill in blank was?
Let me see.
It says the null hypothesis denoted by H naught is a statement that the value of a population parameter, such as a proportion, mean, or standard D, is blank to some point value.
Equal.
Okay. Thank you.
Yes. Is equal. And then we tested to see if second blank.
True.
Yep. See, we assume it's true. Absolutely. And so I think that is as far as we need to go today. But I do want you guys folks to think about this real quickly. So which one of those do you think could be null hypotheses? Take a look. Don't do it now. We're going to do it next time. But just take a look and in your mind mentally pick out which ones you think could be null hypotheses. Null hypotheses are always what? Equals. Everybody on board? All right, we'll do it next class.